In this video, we're going to take a quick look at how to use Microsoft Excel to not only make a scatter plot again, but this time to insert a line of best fit. A trend line is the term that Excel uses. I've got some data here, volumes and masses of different samples of methanol, one of the alcohols that we've used in our lab. I've entered them in my spreadsheet in columns A and B. Column A is volume, column B is mass. It's important that we put them in that way because on my graph I want the volumes to be on the x-axis and the masses to be on the y-axis. So when I put them in this order, the things on the left will be on the x-axis, the things on the right will be on the y-axis. Alright, so now one thing you'll notice is that the volumes, most of them have one decimal place. That's because we used a graduated cylinder to measure them, and we can read to that accuracy with the cylinder we had. However, Excel doesn't let me, if I put in a number like 0 or 12, when I meant 0.0 and 12.0, Excel just rounds them off like this and doesn't show the decimals. Look what we can do. We can highlight all of the numbers in the volumes, and then we can right-click and format those cells. On the tab called Number, in the category called Number, we can set the number of decimal places to be one decimal place for all the numbers in that range and say OK. Now the 0 became 0.0 and the 12 became 12.0. My masses were recorded with an electronic balance that went to 2 decimal places. The 0 at the beginning, again, is being rounded off. So I'm highlighting all of the masses and then right-clicking and formatting those cells. And on the Number tab, I go to the category called Number and set the number of decimal places to 2. Press OK, and now that 0 shows up as 0.00. Alright, let's quickly make a scatter plot. We highlight all of the numbers, including the labels, volume, and mass. And now we go up to Insert tab, and we look at the charts, and we want to use a scatter plot. Now, because we're going to put a line of best fit in this graph, a trend line, we're going to just use dots. We don't want to connect the dots with any kind of curves or lines. So just plain old dots is what we want for our scatter plot. While the graph is highlighted like this, we have access to chart tools, and right here under the Design tab we can move the chart. So let's do that. Over here on the right, move the chart. And now we want to set it to a new sheet. Press OK, and here's our graph on its own sheet. We know already how to manipulate this a little bit. We can click on the vertical y-axis and right-click and format that axis. We know how to set the minimum and maximum values. I'm pretty much okay with what's here for this, but maybe I'll just show, actually, you know what, maybe I'll change the major unit from 5 grams to 2 grams. I'll see what that looks like. And then I'll go to the minor tick marks and I'll say show them outside. There we have it. Now my y-axis goes 0, 2, 4, 6, 8, and then there's minor tick marks showing up. I'll press close there. And now on the x-axis right now, it's looking pretty good, but maybe one thing I'll do is I'll add some grid lines. I'll add major grid lines, and then again, right-clicking over the horizontal axis, I'll add minor grid lines as well. I'll click on this legend and delete it. We don't need a legend since there's only one set of data. And now if we go up here to the layout options, now if you don't see these menus, then you don't have your graph highlighted. For example, if I click outside somewhere, then notice the menus are gone. If I click on the graph, then I have access to chart tools. If I go to the layout features, I know how to set in there the titles of the axes. For the horizontal axis, we can say that this is volume, and the units were milliliters. And now I'll go to the y-axis, the vertical axis. I'll use a rotated title, and I'll say this is mass in grams. There we go. The title of the graph is not supposed to be mass, so I'll change the chart title to Actually, I'll leave it the way it was there above the chart, and I'll change the title from mass to something like density of methanol, since that's what we're going to be finding from this graph. So there's a pretty good looking scatter plot just now. I could probably copy and paste that into my lab report or print it out like this if I was handing in a paper report. But we want to put in here a line of best fit, and we'd like the computer to do that for us. We don't want to have to just draw it ourselves after printing the graph. Now look how we do this. We see the data points. There's 1, 2, 3, 4, 5, 6 data points. I'm going to click on any one of them. So just click on any data point, and you'll notice that all of them get highlighted when you click on one of them. If you right-click on that data point and say Add a Trend Line, that's the menu that comes up, Add a Trend Line. That's Excel's language for line of best fit. Okay, so let's add a trend line, and look at the options we have. We can add a linear trend line, and looking at our data, that looks pretty good. It looks like a straight line. And there's these other types that we could add based on the shape of the graph. For now, we just see a straight line graph, so we're going to say linear. We can forecasting forwards and backwards. This would be extrapolating from your graph, making it not just start at the first data point and end at the last data point, but you could say, for example, forecast forward. If I say forecast forward 2 milliliters, then what happens is, if you look at the trend line, it has gone past this data point by 1, 2 milliliters. So sometimes you want to extend your trend line past your data, and you can do that by forecasting forwards or backwards. If I go backwards by 2 milliliters, then notice now it extends past the first data point by 2 milliliters. I don't really want to do that here, so I'm just going to set that back to 0 for both of them. And you'll notice now that we're back to our original looking graph. But one thing I do want to do, a couple things. Down here at the bottom, you don't always want to do this, okay? But on our graph, we know for sure that if there's 0 milliliters of methanol, its mass would be 0 grams. So I'm going to set the intercept to be 0. That means the graph, the line, must pass through 0, 0, the origin of the graph. You don't normally want to do that on a graph with data like this, but because we know for sure that that's a data point, I'm going to put that in. I also want to see the equation of the line. That's the whole point of putting this trend line in. So show me the equation of the line. Click off the display equation on chart. The R² value is a measure of how linear your data is. I'm not going to put that here, but looking at our graph, our line pretty much goes through all of our data. So if we clicked display R² value, it's going to give us a value very close, in fact equal to 1 in this case, which means the graph is perfectly linear. The closer that value is to 1, the more linear your data was. I'm just going to get rid of that. I just want to see the equation. I'll press close. Here's my equation. You probably can't see it, so I'll drag it down. I'll increase the font for the equation so you can see that. There we go. And notice that the equation of the line is y equals 0.7879x. Because we told it to go through the origin, the y-intercept is 0 and is not shown here. If you want to get a bit fancy, we can click inside and we can change the y value. Because our y-axis has mass, we can say m instead of y. And our x-axis has volume, so instead of x, I can say capital V for volume. The slope of the line, 0.7879, has quite a few significant digits, so I'm going to delete some of those, 0.79, to reflect the significant digits in my volume. I think we had 2 sig figs for 1 or 2 of those volumes. And I'm just going to click outside there. There's the equation of that line. M equals 0.79V. Now I said the title of this graph is density of methanol. If you think about the slope of this line for a minute, you'll realize that the slope, rise divided by run, is actually mass divided by volume. The slope of this line is the average density of methanol for all these 6 samples. So 0.79, the slope that shows up there in the trend line, is the average density of methanol based on these 6 data points. So graphing like this is a better way to find average density because it's based on not just one sample, but in this case based on all 6. And then using a technique like Excel to tell us the slope of the best fit line through the data gives us the best estimate of the densities of our methanol samples. So there we have it. Here's a graph which could now be copied and pasted into a Microsoft Word document or printed for a paper lab report. So we've learned here not only how to do a scatter plot, but how to insert a line of best fit and show the equation for that line as well.